Welcome to this explainer. We've all been there, staring down a massive business problem, just completely frustrated, throwing solutions at the wall and praying something, anything, actually sticks. But the defects just keep happening. Well, what if you could replace all that guesswork with a rigorous, data-driven detective kit? Today, we are exploring Kaoru Ishikawa's 7 basic quality control tools. This is a brilliant framework that actually empowers you to investigate, analyze, and solve your operational mysteries with absolute precision. Okay, let's dive right in.
So here's our roadmap for the investigation. 1. The problem-solving toolkit. 2. Collecting data. 3. Finding root causes. 4. Visualizing patterns. 5. Monitoring stability. And 6. Empowering your overall quality journey.
All right, starting with Section 1, the problem-solving toolkit, or as I like to call it, accessible analytics.
There's this massive misconception in quality control that you somehow need a PhD in advanced mathematics to fix real-world operational issues. Honestly, I absolutely love this quote from our source material because it just shatters that myth. It says, "They are called basic tools because they are suitable for people with little formal training in statistics and because they can be used to solve the vast majority of quality-related issues." So no advanced degree required, guys. These are literally designed to empower everyday folks.
So, what are they exactly? Well, the 7 QC tools are essentially simple graphical techniques. You use them to collect data, analyze patterns, pinpoint problems, and keep an eye on process performance. The whole overarching purpose here is to take all that raw, confusing, operational data and translate it into crystal clear, visual, and highly actionable insights. Moving right along to Section 2, collecting and organizing data. It's time to gather some clues.
Okay, so this is phase 1 of any good problem-solving endeavor, gathering hard evidence before we jump to any conclusions. And our very first tool in the overview is the check sheet. Imagine a restaurant tracking customer delays. Down the left-hand side, you've got problems like long wait and cold food, and then the days of the week across the top. All those marks tally up to 74 total defects. What this brilliantly shows is how frontline workers can capture real-time defect frequencies right at the source without messing up their actual workflow. It's incredibly straightforward.
And what's genuinely fascinating is just how effortless this is in practice. Notice the simple tally marks here tracking real-world telephone interruptions. By structuring data collection this way, documenting things becomes super organized. You can instantly see that wrong numbers and the boss are the absolute main culprits here.
Now onto our second tool, stratification. Think about unstratified data, like a messy, confusing list of random dates an employee was late. Honestly, that list tells us pretty much nothing. But when we stratify that data, meaning we sort those exact same dates meaningfully by the day of the week, a crystal clear pattern suddenly pops out. Stratification is basically a filter. It instantly separates the vital signal from the background noise just by breaking aggregate data into logical subcategories.
That brings us to Section 3, finding the root causes. Let's go identify our prime suspects.
So now that we've collected our initial clues, we actually have to figure out who or what is to blame. This is where we bust out tool number 3, Ishikawa's cause and effect diagram, which you probably know better as the fishbone diagram. It's a structured 4-step process. First, define the problem. That goes right at the head of the fish. Second, identify the major categories. People usually use the 6 M's here, like machine, method, material, and manpower, serving as the major bones. Third, brainstorm specific causes that branch off those bones. And finally, analyze and prioritize. It is simply the best way to turn a chaotic brainstorming session into a clean, logical map.
Speaking of prioritizing, we absolutely have to talk about this magic number, 80/20, the Pareto principle. This is a foundational concept in quality control, stating that roughly 80% of your negative effects almost always stem from just 20% of your causes. It's the universal law of the vital few versus the trivial many.
And that exact principle gives us our 4th tool, the Pareto chart. When you build one of these, you arrange your problem categories in descending frequency using bars, and then you track the cumulative percentage with a line graph. Let me give you a great example. A telecom company actually used this method to evaluate their service downtime. They discovered that a whopping 75% of their outages were caused by just 2 specific issues, fiber cuts and server overloads. By identifying their vital few, they knew exactly where they needed to spend their upgrade budget. It's a real game changer.
All right, Section 4, visualizing process patterns. It is time to analyze the evidence.
Up until now, we've looked at discrete categories, but here, we're transitioning to analyzing continuous variables, basically hunting for the hidden shapes inside our datasets. Enter tool number 5, the histogram. A histogram groups continuous data into visual intervals, or bins. For instance, this chart displays manufacturing process failures grouped into specific testing categories. We use histograms to see what a process is genuinely capable of. In a perfect world, we're looking for a nice, stable, bell-shaped curve. But if the distribution is skewed, or say has 2 distinct peaks, well, that's a huge clue telling us the process is off-center, or maybe we're accidentally mixing 2 entirely different data sources together.
Next up is tool number 6, the scatter diagram. This one brilliantly visualizes whether a change in one factor actually influences another. You just plot 2 variables against each other. The graph clearly shows a positive correlation going up, a negative correlation going down, or just a random scatter, which means there's absolutely no correlation at all. It completely takes the guesswork right out of cause and effect.
Moving right into Section 5, monitoring process stability. This is all about keeping things in check.
We've reached the final phase of our toolkit, and this is designed to ensure that once you actually fix a process, it stays fixed over time. This is our 7th and final tool, the Shewhart control chart. It maps data continuously. Notice point A. It's fluctuating, sure, but it's totally within the normal expected range. We'd say it's in control. But then look over at point B. It spikes dangerously outside that top dotted line. That process, it is officially out of control. It's a huge red flag indicating a special cause of variation that needs immediate attention.
So the crucial thing here is understanding the strict anatomy of this chart. You've got a central line which represents your historical process mean. Then you establish these strict statistical boundaries, the upper control limit, or UCL, and the lower control limit, the LCL. Anything, and I literally mean anything, falling outside those UCL or LCL boundaries acts as a loud alarm bell for management. It beautifully differentiates your normal, everyday background variation from a specific abnormal problem that you need to go investigate right away.
And finally, Section 6, empowering your quality journey. Let's look at your complete toolkit.
We've spent this explainer focusing on each specific tool individually, but the real magic happens when we zoom out and view them together as a unified system. The biggest takeaway here is that every single tool has a highly specific job depending on exactly where you are in your improvement cycle. Need to measure and identify issues? Deploy your fishbone and Pareto charts. Want to deeply assess and analyze the data you found? Pull out your scatter diagrams, histograms, and check sheets. And when you need to sustain that quality over the long haul, rely continuously on your control charts.
Which leaves us with one final thought to ponder. If the Pareto principle holds true, and 80% of your problems really are coming from just 20% of your causes, well, which of these 7 basic quality tools are you going to use today to find your vital few? Thank you so much for joining me for this explainer, and good luck with your investigations out there.